So we're just going to continue on with what we started talking about yesterday on line graphs. We already did question A and question B yesterday, so we're just going to keep going on this particular example.
Sorry, something that we're just trying to discuss and they're trying to figure out now. So the question is that, okay, let me use this one. How do we know the point is here, not here, and not here? So they are confused, like this one.
64?
Yes, so how do we know the particular
Oh, this
point?
is 1957 and 1972. It's around seven years after.
So how do we get our 7 years?
7 years, so
they're
that's
asking me, I don't know.
1964 minus 1957.
That's 15. Okay, no, what
Yeah.
did we do?
1964, 1957, that's 7 years. 1964 minus 1957.
Okay, you minus this
Yeah,
then. Okay.
minus this part.
This part, okay.
So now you have 7 years from there.
From there, okay.
From here to here is 15 years.
Yes, yeah.
1972 minus 1957, so 15 years. So
from
7
there.
years would be somewhere in the middle.
Somewhere there, okay, I see. Thank you.
Yeah, no problem.
Where's my own copy? Yeah, this one. Thanks.
Okay, so let's take a look at question letter C. Predict the population in 2012. Now, as you can see, 2012 is nowhere in our picture. Nowhere in our picture. 2012 would be above, right? So what we could do is, if this is 2002, that's going to be extrapolation. So this is, if we go 2002, as you can see, every single one is 15 years in between. Okay, everyone is 15 years in between. So 2002, that's going to give us 2017 is the next 15 years. So where is 2012? So 2012 would be 10 years from then on. So 5, 10, 15. So 10 years more that we gotta add. Okay. We use a straight edge, a ruler. Okay, I'm just kind of eyeballing this. Okay, so we're kind of eyeballing it. So it's going to be somewhere right there. It's supposed to be a straight edge, not let me try to find a straight edge here. Found a straight edge. Straight edge up. Okay, so it's going to be somewhere up there. Now, this trend, we know that it looks like it's going up, right? It keeps going up. So if we can assume that this is going to go up, we can say it's going to be approximately 30, approximately, we might get really, really close to about 35 million, okay, or if it's higher above, would be about 36. So, okay, yeah, so that's okay, 35 or 36 million. You can put 36 million. I'm gonna write down 35 million so that it matches with my graph over here. Okay, so that's how you would extrapolate. The word extrapolate means extra, that means beyond what you have, right? Yeah. Now, as you can see, this one here is not going to be exact to the point, right? It's not exactly, we're approximating, right? So we're approximating the number of people. Okay. let's take a look at example number 2. Example number 2. Okay, what does this talk about? Dollars and year. So that's relating dollars and year. Well, dollars and year of what? Annual wages of bus drivers. Oh, okay. So what do you think the trend is? What do you think is happening to the wages of the bus drivers? It's going up, right? It's going up because it's increasing up this way. It's not falling down. So, describe the trend of wages of bus drivers. Use words like upward, downward, increase, or positive or negative. So this one here is there's an upward trend. Okay, upward trend in our graph. And we can say that the wage increases as year go by, right? So the wage increases as time goes by, or as year goes by. So looking at this graph, okay, and maybe some of you have science class. You see a lot of graphs in science, something similar to this. Letter B. What was the average wage of a bus driver in 2013? So let's search for 2013. I'm gonna zoom it in. If you need a ruler, I have some ruler to spare. So if you need a ruler,
Get some out here.
here.
You have? Okay.
This is a good one. We have some over here as well, so anybody who needs a ruler, you can come up here and we can.
It's good, yeah. Is this yours?
Yeah.
I brought some of them.
Oh. Okay, so how do we look for? Everybody has a ruler now?
Yes.
Yeah? Okay. I have a really nice one here too. Sometimes clear one works really well. So help yourself, they're at the front.
At the dollar store, there's geometry sets for $2. So just
Oh,
so that
sweet.
you guys know.
Okay, awesome. Awesome. Yeah, let's do that one. Yeah, it has a protractor too. We might need it for geometry and trigonometry. Okay, so 2013. Okay, where's 2013? 2013 would be somewhere here. So 2008, 2009, 2010, 11, 12, 13. Can you see that there's an equal spacing between the number of years? Okay, equal spacing between the number of years. So 2013, where's 2013? It's right there. So we're gonna make sure that we draw a line straight up. This one here doesn't have a lot of grid. Would have been super nice to have grid on this, right? It's just some lines. So if you take a look at that, 2013, okay, so do a straight line up and then straight line across.
It's right on.
Right on.
Yes, right on.
Okay. So 2013, you locate it, draw a straight line up, and then draw a straight line across, and then we'll see how much is that. 26,000. Okay, so the average is $26,000. Okay, the average wage. Annual. Oh, well, not bad. That's in 2013. Yeah? Is everybody okay with that one? You're comfortable? Okay. Let's take a look at letter C. Predict the average annual wages of bus driver in 2016 by extrapolation. The word extrapolation, why do you think it's called extrapolation? Just, we don't have data around that time, right? 2014, 2015, 2016. Okay, now we gotta draw a straight line up. Draw a straight line up. We're gonna make some predictions. How do we predict this part here? We're gonna predict that this line is gonna continue on. Is that okay? We're gonna predict that this line is gonna continue on. So extend this line as well. I'm going to extend that line. So they meet at that particular point. Now we're going to do the horizontal line after. Okay, so that's basically it.
I was just coming in early, class at 12, but I was going to see if I can use a computer to finish my English project.
Okay, well, that's kind of looking at that, like, how do we predict? Okay, let's see. I haven't talked about the word increment yet. Increment means how much do they go up by? What do you think they go up by in here? 2,400, and then, sorry, not 2,400, 24,000, 24,500, 25,000, 25,500. What do you think is going on? What is it? What is the increment? What is it going up by?
500.
500, right? So this much space is increased by 500. So how much space is that? Okay, how much space is this part here? This is about 5 centimeters? About 6 centimeters?
No, it would be 5 because then if you divided 500 by
100, yeah.
it would be 250.
Mm-hmm.
So then you go by 1.
So this one here is increments of 500, going up by 500 each time. So this part here is about the same height as that, same width. So this is approximately 27,500. So approximately, we're approximating here 27,500. So we're assuming that the line is going to continue on. Okay, so that's the first thing that we did. We're making a prediction that the line is going to keep going up. So we extended that line. And then we extended the 2016 up. And then horizontally to figure that out. Okay, yes? You like it? Extrapolation, because it's beyond our graph. Okay, so now let's see what this line is about. What's this line about? Interpreting a double line graph. So there are two lines going on here. Okay. What's on the horizontal axis? What kind of information is on the horizontal axis? Years, right? Horizontal axis is right here at the bottom. That's horizontal. Horizontal axis are the years. What's on the vertical axis? Yeah, so this is the vertical axis, going up and down, number of cars sold. You would probably see a legend. Legend. Yeah. No, the other legend. Oy. Never a dull moment. Okay, the legend. The legend means like the description of the line. Okay, can you see here? The solid line talks about the used car. So when you look at the solid line, that's this one up here. Talks about number of used cars sold. The dashed line are the new cars sold. So that's this part here at the bottom. Okay. So which one is selling more? Used car or new car?
Used.
Used. How do you know?
2013.
How do you know the used car is more? Because
It's higher
it's above, right?
in the graph.
Yeah, it's higher above the graph. Yes? So, let's take a look and see if we can answer this question. Looking at this graph, in what year were the most used cars sold? In what year were the most used car is sold? So, used car. So, used car is the solid line. So what year would that be? 2013. Did everybody see 2013? Yeah, so this is the highest part. 2013. Okay. Yes. Estimate, next letter E. Estimate the number of new cars sold in 2015. So how many cars are new cars are sold in 2015? Which one are you looking at?
2015.
Yeah, so we're in 2015. How many new cars are sold in 2015? 6,000?
61,000. It's a little old.
Yeah, it's a little bit over. Okay. We can put, because this is an estimate, so we can say approximately 6,000. Or if you say it's a little bit over, like maybe 6,100, that's okay. So I'll just go with the 2015. Where's my ruler again? I'll go for 6,000 because it's an estimate.
So,
2015 is here. Right there. I'm just gonna do the estimate. Approximately, yeah, you're right, it's slightly above, but because it's an estimate, we can say it's approximately 6,000. Yes? Is that okay? So 6,000 what?
New cars.
Cars, new cars. So far so good. Take a look at letter C. The question is, could you make a prediction on how many used cars would be sold in 2017?
New cars?
Yeah. Oh, how many used cars, sorry. Used cars. Could you make a prediction how many used car could be sold in 2017? Now this part in here, can we see a real trend in here? In this case, like it goes down, goes up, goes down. It's hard to make a prediction here because there's no trend that we see. Sometimes it goes down, sometimes it goes up. It's hard to predict. So in this case, could you make a predictions? Probably not. Not because there are a lot of ups and downs. So, and no trend. Is it an upward trend? Is it going down trend? We don't know because there's a whole bunch of ups and downs. We don't know. We can't see the pattern. Okay? Is that okay? So in this case, you can't predict because it's like an up and down stuff. So far so good? Yeah? You understand this thing? Okay. Oh, bar graph. So the past few examples that we've seen, those are called line graphs, right? Because you have a whole bunch of lines. Now this one is called a bar graph because it looks like a bar going up, right? And bar graphs could be going up, but it could also be horizontal, right? You know, I think I have such great ideas about this, and I think we have enough computers for everybody, or maybe enough computers for everybody. You might be able to, I might be able to show you an Excel program to create graphs. Okay, I'll show you graphs by hand, to do it by hand, but we have available technology around us that we could certainly use technology. I'll show you how to do Excel program later, okay? Maybe some of you already know how. So bar graph. The bar graph below shows the prices of burgers at 5 different restaurants. So I'm going to ask you this. What's on the horizontal axis? Okay, restaurants, right? Horizontal is on the flat, right? That's horizontal is a flat. This flat here. These are the restaurant names. Now, what's on the vertical axis?
The prices.
Can you write that in there?
Yeah, I could write it down. So this part here is called the horizontal axis. Okay. The flat part, right? The bottom part. Now, if you're going to get into the mathematical part, it's called the x-axis. We're not going to call it x-axis. We're just going to call it horizontal axis. And then the one that's going up and down, this is called the vertical axis. Vertical axis. The ones that's going up and down. So as you can see, the horizontal axis has the restaurant names, and then the vertical axes are the prices. So, looking at this, let's see if we can answer some of the questions in here. List the restaurants in ascending order. Ascend means, the word ascend means going up. So from lowest to highest by price. So list the restaurants that has from lowest to highest by price. So which one is the lowest? Missy's Burger. Okay, is everybody okay with that one? That's the lowest. What do you think is the next one? Okay, how do you know?
Because it's slightly under the $8, so it's like approximately at $6.75.
Okay, yeah, you can say, yeah, so this is McWhopper. Yeah, from lowest to highest, lowest price. Okay, what's the next one? JJ Burgers. What's after JJ's? Mama's Place. And what's after Mama's Place? Burgers R Us. I'll just gonna put it here. Okay. That's exactly what I was thinking about. Yeah, after this we can go for lunch. Yeah. Burger. Yeah, I just don't know where these burger places are. Okay.
You guys ever tried Blondie's? You guys ever heard of Blondie's?
I have.
That's a little big burger. That's a huge
Yeah,
burger.
by Kildonan Park.
And there's a little, what was she called? 97-pound Asian lady? She ate that whole burger.
She's the only one that passed off this place
A little Asian lady, she came from Asia, the town, that burger company contest. She's just a little chick, man. She ate that whole burger to herself.
or one of his stomachs.
And there's a picture of her there.
Oh wow. Wow.
And I'm thinking that burger's probably half her weight.
Oh, we could actually buy one of that burger and share it all with all of us. Yeah.
It's $187.
Wow.
Yeah.
One burger. It's huge. Huge.
And
Yeah.
the fries, oh my god, it's like 10-pound fries, but like basically.
Yeah.
Blondie, is still open. I know about it.
It's by
Maine.
Kildonan
Maine and,
Park.
Wasn't it?
What's that street that goes Seven Oaks Hospital right across the Main?
Leela?
Leland. Main Leland.
Well, past Leela.
Yeah, a little bit that across the map. Yeah.
Closer to.
But it,
Yeah. Okay. Yeah.
and for a single burger, like that big, like you have to cut it in half.
Well, we can Google it later.
Yeah.
It's huge burger.
Check that out. You're gonna like that.
Okay. Now we're like thinking about burgers and lunch. Okay, let's take a look at letter B.
You know the fact your tummy is wrong? I did it.
The price of Mrs. Burger is approximately half of which other burger? The price of Mrs. Burger is half of what burger? Burgers are us? Is it really? How do you know?
Because if you,
It's like from here, half. Yeah. So burgers are us.
Yeah, it looks about it, right?
Oh, why did I put use? Burgers are us.
25 cents.
By a little bit, approximately. Yeah. Which is more expensive, burger at McWhopper's or burger at JJ's? Letter C. Which is more expensive? Burger at McWhoppers or burger at JJ's?
JJ's,
How do you know?
because it's 25 cents more. Because in between $6 and $8 is $2 difference, but it's slightly over a little bit. Then
It's about 35 cents.
Yeah, okay. So McWhoppers is here and JJ Burger. So they're very close in height, right? They're very close in height. But this one here is like right at $8. This one is just probably like $7.95. I don't know. So we say
taxes, it would be 8 cents.
almost, well, with taxes, yeah. Bring back our old one. So JJ's, say JJ's Burger. Okay, estimate the price of burger at Burgers R Us. How much is that approximately? Okay, so burgers,
It's about 12.25.
okay. So how do we figure that out?
In inches.
25%.
Now, from here, from $12 to $14, we know that's a $2
Oh, okay, well,
increment, right? So we know that this is a $2 increment.
that's 50 cents then.
Oh, in centimeters.
So if we find a half of that, where's a half approximately? Half of that is there. That would be what?
13.
$13. So between 12 and 14, the half is $13. Is it $13?
No,
Is it above or below?
below.
Slightly below. So this is my $13 mark. Oh, no, I didn't do a good job. It's slanted. But that's a $13 approximately there. And it's slightly below. So it's below $13. So now it's going to be between $12 and $13. So we can say approximately $12.50. Okay, so that's how you would think about it. So what are the increments here? Okay, and then that's $2 difference. So if you cut it in half, so that's $13.
And make 4
And then
quarters.
it's like, yeah,
And it would make up to 4 quarters.
yeah,
So then you would calculate by inch,
yeah,
and then go by 2 inches by up, and it would be $12.50.
yeah. Probably by centimeter
Yeah,
or millimeters, yeah.
Yes.
Yeah. So this one, what did we say? It's $12.50, approximately $12.50. Okay, now let's take a look at this one. Estimate the price of burger at Mama's Place. Mama's Place, where's Mama's Place here? Yeah. So how much is it? Where approximately is it? We know it's between 8 and 10, right? Okay, so that's $2 difference. If you cut it in half, that's $9. Is it exactly half? Not really, right? So, I'm gonna bring this closer to me here. So this is like approximately half. The halfway point is $9, but it's probably less than $9. So that would say $8.50. $8.50 for a burger? That's expensive.
Better to make your own.
Better come with fries and drinks. Yeah, now all I can think of is a burger. Okay, is everybody okay with this piece? Yeah? You like it? It's okay. The next one is called histogram. Now, histogram. Okay, well, what is a histogram? Because earlier we looked at bar graph. This one is a histogram. What's a histogram? They look like bar graph to me as well, but okay. So a histogram resembles a bar graph, but the bars of histogram represent the frequency of a particular value. Frequency, okay, what's frequency? When I say, oh, it's very frequent.
The players,
Okay, what does frequency mean? Once in a while, or you see it often, right? Okay, we have a dictionary here. Let's use it. Let's see. What does the word frequency mean? Frequency. Frequency. Oh, we never really use dictionary in math class. Wow.
well, we don't have our thinking brains today.
I'm trying to say what brain cells brain.
No, you're actually growing brain cells as you speak. Frequency. Yeah, there you go. Frequent. There we go. Frequent. What's frequent means?
Occurring often, near together.
Occurring often, near together, or every little while, or regular occurrence, right? That's what occurrence, frequent is. So when we say frequency, it means how many times it occurs. So how many times something is happening. You know, like in math, there's like some words, and we want to make sure we understand those words. So frequency. The bars of the histogram represents frequency, which is how many times something is happening of a particular value, for that particular value. So you take a look at this, the following histogram. Okay, so let's talk about horizontal. What's on the horizontal axis? Height. Horizontal axis is a height, right? What's on the vertical axis? Vertical frequency or number of players. So how many are in that category? So if you take a look at this, it's not just one number. It's 173 or less. Kind of gives us this range of numbers. And then on this graph, it's 173 to 178. And then here, 178 to 183. Okay, so there's a range of numbers in here. So the next question, okay, next question, letter A. In total, what is the meaning of total?
The amount.
Okay, amount of, the word total means
The whole thing.
the whole thing, yeah? What operation would that be? Addition. Yeah, the whole thing, addition. When we add them together, the total, when we add everybody together, how many total players are on the team?
15,
Ah, how do you know? How do you know?
because I added all the players in the height in each of them.
Right, okay.
The first one has 2, the second one has 5, the third one has 3, and the fourth one has 2, and the last one has 3.
Okay, okay, good. So what we are seeing here is that people in this group, right, basketball players, there are in this category, a height of 173 or less, how many are in this group, in this category? Two, right? So the highest is 2. How many are in this category? 5 people in the second category. Okay? How many are in this category? 3, right? And then 2, and then the last category, there's 3. So how many in total players? So that's going to be 2 plus 5 plus 3 plus 2 plus 3. Okay. How many is that? 15. So 5, 10, 15. So 15 players. Awesome. How many players are between 173 to 178? How many players are between 173 and 178? 173 to 178. So that's 5.
You don't include the first.
Sorry. No, that's less. That's less than 173. Yeah. Only 5 players. Okay. Letter C. Okay. Let's see if we can figure this out. Can you determine the height of the tallest person on the team? Can we determine the height of the tallest person?
No.
We don't know.
No?
Because
Why not?
it's not stated. It's not stated who is the tallest.
Yeah. Okay, no. Yeah, you're right. It's like, no, we can't. Very good. Because it is not stated. The only thing that's stated is how many people are in that category, but they didn't really tell us what is their height. Right? Very good. Everybody had a chance to talk, I hope. Letter D, how many players are between 178 and 188? Okay, 178 to 188. How do you know?
78 starts, 178 starts at 3.
Mm-hmm.
Then 88 ends at
Right here, right? So you're looking at these 2 bars, right? Yeah, so that's 3 plus 2, which is 5. Yeah? 3 plus 2. So 3 plus 2. Now this one here. Now we're going to take a look at letter E, and then we'll probably see what this one. What percent of players are shorter than 178? What percent? It's not asking for how many, but they're asking for what percent. Well, we're going to figure out how many first. So, how many are shorter than 178?
7.
Okay. This one here is up to 178, right? So that's going to be 2 and the 5. So that's 7. Okay? So how many are shorter than 178? Let's figure that out first. We said that's 2 plus 5. Okay, so 7 players. But that's not what the question is. The question is, What percent? Well, what percent is that? So 7 out of how many players are there? 15. 15. So 7 out of 15 players. So 7 divided by 15 players are shorter than 178. Okay, that's gonna give us the fraction times 100 to make it 100%. So 7 divided by 15. So let's give that a try. So 7 divided by 15. 0.6 repeating. Yes? Okay, now we're gonna make it into a percent, so times it by percent. 100. So 46.67%. So approximately half, close to 50%, are shorter than 178 centimeters. Okay? Yeah, wait. Yeah. Okay. I think what we're gonna do is we're gonna stop right here. We're gonna continue on tomorrow. Yes. Yeah. Now you can go and have lunch. Okay.
Wait first and leave it up for a second.
Yeah, I'm gonna leave it here for a second. Okay.